1. Context of earthquake activity in Idaho and Yellowstone. Earthquake activity near Yellowstone, a growing concern. In recent weeks, a series of earthquakes has been recorded in Idaho, a region located near the Yellowstone Supervolcano. While earthquakes are not uncommon in this region, the frequency and magnitude of these recent quakes have raised concerns. Idaho, sitting near the Yellowstone caldera, is geologically active, and any seismic activity near this supervolcano is closely monitored due to the potential risks associated with Yellowstone's eruption. Yellowstone Supervolcano, one of the world's most well-known and potentially destructive supervolcanoes, lies underneath a vast area that stretches across Yellowstone National Park. Any minor or major earthquake swarm occurring nearby could potentially signal increased volcanic activity or shifts in magma pressure within the caldera. Historical context: Yellowstone's eruption potential. Yellowstone has had a long history of significant volcanic activity. Its last major eruption occurred around 640,000 years ago, which left behind the Yellowstone caldera, a vast volcanic crater formed from the collapse of the Earth's surface after a massive eruption. This eruption was so powerful that it caused global climate disruptions, leading to what is referred to as a volcanic winter. Although no eruption of this scale has occurred since, scientists have emphasized the inherent risk that Yellowstone poses as an active supervolcano. The seismic activity in Idaho raises concern because it suggests that the Earth's crust beneath Yellowstone is far from stable. Earthquakes, even if relatively small, can indicate shifts or increases in magma movement, potentially increasing the likelihood of a larger eruption. Tectonic plates and geothermal activity in the region. The tectonic setting of Yellowstone plays a crucial role in its geological activity. The region sits on the North American plate, but it is also influenced by an underlying hotspot of magma that powers the volcanic system. This hotspot creates the geothermal activity Yellowstone is known for, including hot springs, geysers, and fumaroles. The relationship between tectonic plate movements and geothermal activity beneath Yellowstone is complex. Earthquakes in the area may be a sign of tectonic adjustments, but these can also influence the magma chambers beneath the surface. The frequent magma movement could increase pressure within the caldera, triggering earthquakes as the ground attempts to adjust. Monitoring the seismic activity, a precautionary measure. To better understand the risks associated with the seismic activity near Yellowstone, scientists have implemented seismic monitoring systems to track earthquakes in real time. The United States Geological Survey, USGS, and other research institutions continually monitor the region for signs of unusual seismicity that might indicate a larger, more significant event. The seismic network consists of thousands of seismometers, which detect even the smallest tremors in the Earth's surface. The data collected can provide early warning signs, giving local authorities and the public time to prepare for any potential risks. The role of earthquake swarms in volcano monitoring. Earthquake swarms, like the one occurring near Idaho, are a common feature of volcanic regions. Historically, swarms have often been observed before major volcanic events, such as eruptions, though not all swarms lead to catastrophic outcomes. A swarm of earthquakes near Yellowstone, therefore, raises important questions about the stability of the magma beneath the supervolcano. These seismic swarms are usually caused by pressurized magma pushing through the Earth's crust or shifting beneath the surface. As magma moves upward, it causes small earthquakes, which serve as early indicators that the volcano may be experiencing increased activity. However, scientists need more than just earthquake data to predict whether a full eruption will occur. Two, earthquakes and their link to Yellowstone Supervolcano. Earthquake swarms as a warning sign. Earthquake swarms in regions like Yellowstone are often seen as potential precursors to volcanic activity. In areas near supervolcanoes, frequent seismic activity, especially swarms, can indicate increased magma movement beneath the surface. Earthquakes are caused when magma shifts under the Earth's crust, leading to cracks and stress, which results in seismic activity. This movement can cause pressure to build up within the Yellowstone magma chamber, and if this pressure becomes too great, it could potentially lead to an eruption. Earthquakes and magma movement. The connection between earthquakes and magma movement beneath the Earth's surface is key to understanding the seismic activity in the Yellowstone area. When magma rises toward the Earth's surface, it creates pressure on the surrounding rocks, leading to fracturing and earthquake swarms. These movements are often the result of magma trying to make its way up, displacing rocks along the way. As magma continues to push upwards, the frequency and intensity of earthquakes might increase, giving scientists clues about the potential for an eruption. Volcano-triggered seismic events. Seismic activity in and around Yellowstone may not always be directly related to volcanic eruptions. While volcanic-triggered earthquakes may not always result in eruptions, they often serve as indicators of geothermal system fluctuations. Geological models and predicting volcanic eruptions. Geological models that track earthquakes, ground deformation, and gas emissions are essential tools for scientists trying to predict volcanic eruptions. While earthquake swarms alone are not enough to definitively predict an eruption, they contribute to the bigger picture. Scientists use the data from these earthquakes to build models of the region's geothermal system, which can then be analyzed for signs of heightened activity, such as increase in pressure or magma accumulation. If these conditions continue, it may suggest that an eruption is becoming more likely. Monitoring seismic activity for early detection. While Yellowstone's earthquake activity doesn't necessarily indicate an imminent eruption, it is closely monitored by scientists who rely on seismographs and other monitoring equipment. In conclusion, while earthquake swarms in the Yellowstone area are part of the natural geological processes occurring beneath the supervolcano, their occurrence serves as an important tool in understanding and predicting potential volcanic behavior. Three, the dangers posed by Yellowstone Supervolcano. Catastrophic eruption and global impact. The Yellowstone Supervolcano poses one of the most significant natural threats to the planet. A large eruption from Yellowstone would be catastrophic, not only for the immediate vicinity but for the entire world. Such an eruption could discharge a massive amount of ash, volcanic gases, and debris into the atmosphere, leading to global cooling or a phenomenon known as a volcanic winter. This would significantly lower global temperatures, disrupt ecosystems, and severely damage agricultural production, leading to food shortages worldwide. Yellowstone's massive magma chamber. At the heart of Yellowstone's threat is its magma chamber, which is vast and continuously monitored by scientists. It sits beneath Yellowstone National Park, and while it has not erupted in over 640,000 years, it remains an active system. While the magma beneath Yellowstone is not currently showing signs of imminent eruption, scientists continue to track geothermal activity such as geysers, hot springs, and fumaroles, which are indicators of ongoing volcanic processes. These activities signal the presence of molten rock and are essential for understanding the volcano's health. If the magma chamber were to fill with more material or experience additional pressure, it could trigger a violent eruption. Past eruptions and their impact. Yellowstone's history of eruptions is marked by 3 major supereruptions, the most recent occurring approximately 640,000 years ago. Each of these eruptions was capable of causing global-scale destruction, with ash fallout reaching across continents and disrupting ecosystems. These historical eruptions left behind the massive Yellowstone caldera, which measures approximately 30 miles across. The last eruption was so intense that it caused dramatic changes in the Earth's climate and landscape, including the formation of the caldera that now defines Yellowstone. Earthquakes and ground deformation as warning signs. Recent earthquake swarms and ground deformation near Yellowstone serve as warning signs for increased activity beneath the surface. Earthquakes are often caused by the movement of magma beneath the Earth's crust, which can create pressure and result in tremors. Current risk and scientific monitoring. Despite the dramatic potential consequences of a Yellowstone eruption, scientists assert that the probability of an eruption in the near future remains low. Current monitoring systems, including seismographs, GPS measurements, and gas monitoring, help scientists track any unusual activity. The goal is to detect signs of increased volcanic activity early, which could provide early warnings and allow for preventive measures to protect human life. While Yellowstone poses a serious threat, it's important to note that it is not an immediate danger. Four, the link between earthquakes and supervolcano eruptions. Earthquakes as indicators of magma movement. The connection between earthquakes and supervolcano eruptions lies in the movement of magma beneath the Earth's surface. In volcanic regions like Yellowstone, earthquakes are often caused by the shifting of magma or pressure changes within the volcanic system. When magma rises toward the Earth's surface, it creates tensional stress on the surrounding rock, leading to cracks or fractures, which in turn cause seismic activity. This activity, in the form of earthquake swarms, can be an indication that magma is moving beneath the caldera and increasing the pressure within the magma chamber. Although not every earthquake swarm leads to an eruption, the intensity and frequency of seismic activity are important to monitor, as they can signify an increase in the geothermal activity beneath the surface. Tectonic activity and faults near supervolcanoes. Supervolcanoes like Yellowstone are often situated near tectonic plate boundaries or fault lines, which contribute to the geological instability of the region. The movement of tectonic plates can generate seismic activity as the plates grind against each other. While tectonic activity is a natural part of the Earth's crust, the presence of a supervolcano beneath an active fault line increases the risk that seismic events could trigger a volcanic eruption. Earthquakes as precursors to eruptions. In regions like Yellowstone, where seismic activity is common, the occurrence of an earthquake swarm is one of the key signs that magma may be moving closer to the surface. This can indicate that the volcanic system is becoming more active. However, not every earthquake swarm results in a full-scale eruption. Scientists study the nature and characteristics of these swarms, such as their depth, magnitude, and location to assess the likelihood of a larger volcanic event. Monitoring seismic events for early warning. The connection between earthquakes and volcanic eruptions has led scientists to focus on earthquake monitoring as a critical component of volcano hazard assessment. In regions like Yellowstone, seismographs are used to track even the smallest tremors, which can help scientists understand whether the seismic activity is related to magma movement or other geological processes. The role of earthquakes in monitoring Yellowstone Supervolcano. At Yellowstone, earthquakes are not only a symptom of the region's tectonic activity, but also a tool used by scientists to monitor and understand the behavior of the supervolcano. Earthquake swarms are particularly important because they may represent a change in the dynamics of the Yellowstone magma chamber. When there are patterns of increased seismic activity in the area, scientists closely examine whether the swarms indicate that magma is rising toward the surface, potentially leading to an eruption. While the majority of earthquake swarms in the Yellowstone region are not directly linked to an eruption, they do serve as a red flag that volcanic activity could be increasing. Monitoring and analyzing these swarms helps experts predict possible volcanic events and better understand the interconnectedness of tectonic activity, magma movement, and seismic events. Five, is a big one coming? The probability of a major Yellowstone eruption. One of the most pressing questions regarding Yellowstone Supervolcano is whether a massive eruption, often referred to as the Big One, is imminent. Despite ongoing seismic activity and the occasional earthquake swarms in the region, scientists agree that the probability of a major eruption in the near future is extremely low. Yellowstone Supervolcano is indeed active, with its magma chamber constantly monitored by scientists, but it operates on timescales that span thousands to hundreds of thousands of years. The recent earthquake swarms around Yellowstone and Idaho have raised public concern, but historical data shows that earthquake swarms are a natural part of Yellowstone's activity and often do not lead to an eruption. Scientists have observed similar seismic events in the past without resulting in major volcanic events. As such, while the seismic activity in the area needs to be monitored, there is no concrete evidence suggesting an immediate or near-future eruption. Yellowstone's current activity and monitoring. Scientists continuously monitor Yellowstone Supervolcano through seismic surveys, ground deformation studies, and gas emissions tracking. These methods allow experts to understand the health of the supervolcano and provide data on the likelihood of an eruption. Currently, while the region exhibits signs of geothermal activity, such as geysers, hot springs, and fumaroles, this does not necessarily point to an imminent eruption. Yellowstone's geothermal features are primarily due to the presence of a magma reservoir that is constantly releasing heat, but not necessarily leading to volcanic activity. Although earthquake swarms may indicate magma movement beneath the surface, they are often seen as part of the volcanic system's natural cycles. Therefore, while these swarms should be taken seriously, they do not automatically mean that an eruption is coming soon. Historical context, past eruptions, and their impact. Yellowstone has experienced 3 major eruptions in the past 2.1 million years, with the most recent occurring about 640,000 years ago. These eruptions were so large that they created massive calderas and caused global climate changes, including cooling temperatures and agricultural disruption. While these eruptions were catastrophic, it's important to note that the likelihood of such an event occurring today is very low due to the long geological cycle between eruptions. Given that Yellowstone eruptions are separated by hundreds of thousands of years, it is unlikely that the next major eruption will occur within our lifetimes. Instead, scientists are focused on understanding the geological indicators that precede such events to better assess future risks. Public perception and preparedness. While the scientific community continues to monitor Yellowstone closely, the general public's concern about the possibility of a big one has grown, especially with the increasing frequency of earthquake swarms. The media coverage of Yellowstone's activity, including sensationalized reports of a potential eruption, can contribute to the public's heightened anxiety. It is crucial for both scientists and authorities to manage public expectations by communicating clear, evidence-based updates and educating the public about the actual risks involved. Preparedness for volcanic eruptions, including potential evacuation plans and early warning systems, is essential. While the risk of a catastrophic eruption remains low, educating local communities and ensuring that emergency response measures are in place will help reduce the impact of any sudden volcanic activity, should it occur. Conclusion. In conclusion, while Yellowstone Supervolcano remains one of the most significant geological threats due to its potential for catastrophic eruption, the likelihood of such an event occurring in the near future remains extremely low. Earthquake swarms and geothermal activity in the region, although concerning, are natural features of this supervolcano, and not all seismic activity leads to an eruption. While the historical eruptions of Yellowstone were massive and caused significant global climate changes, it is important to remember that these eruptions were separated by hundreds of thousands of years. The current seismic activity and geothermal features observed today are more likely part of the volcanic system's natural cycles, rather than an immediate precursor to a massive eruption. Scientists continue to study the geological system beneath Yellowstone to better understand the signs that would indicate a more serious volcanic event. Despite the ongoing monitoring, there are no clear signs that a major eruption is imminent. The risk of a catastrophic eruption is low, and while vigilance is essential, the public should not panic over the current level of volcanic activity in the region. The big one, the catastrophic eruption that many fear, is not coming soon. However, scientific research and monitoring will remain critical in providing early warnings and ensuring preparedness. Continued efforts to educate the public and improve emergency response plans are vital for managing potential risks and ensuring that any volcanic threat is addressed swiftly and effectively. In short, while Yellowstone Supervolcano is an ever-present natural hazard, it remains a relatively distant concern in terms of imminent danger, and our focus should be on monitoring, research, and preparedness. Thank you for watching the whole video. Please like and subscribe to the channel to watch more interesting videos from us.